Imagine a beautifully minimalist system diagram.
Oh, I love a good system diagram.
Right. Like, we're talking Dieter Rams here. Classic Braun aesthetics from, the 60s or 70s.
Everything is just very restrained and functional.
Exactly.
Yeah.
Totally honest design. So you have these neat, matte gray blocks, and they're perfectly aligned on this warm, off-white background.
Sounds very soothing.
It is.
Yeah.
And these blocks, they represent your company's workflows.
Mm-hmm.
So your sales engine, the customer support queue, product analytics, your internal operations.
All the load-bearing stuff.
Yeah. And it looks incredibly stable. It looks totally rational.
Mm-hmm.
But then, as you look closer, you notice this one tiny, thin, glowing amber wire.
It's one wire.
So one, and that single wire is connecting every single one of those heavy, stable gray blocks back to one small external node sitting off to the side.
And that's where the anxiety kicks in.
Totally, because if that little amber node blinks out...
The whole factory just stops.
Exactly, the whole factory stops. And that is the reality of AI dependency today.
Yeah.
Which is exactly what we are dissecting in this deep dive.
It's such a chilling visual, really, because it captures that tension perfectly. The tension between the illusion of stability and the reality of extreme fragility.
Yeah, and our mission today is really focused, and frankly, it's pretty urgent. We're going to equip you, our listener, with a step-by-step guide to conduct an AI dependency fire drill right within your own organization.
Which is something almost nobody is doing yet.
Right. So we're pulling from this fascinating stack of sources today. Cross-platform thought leadership essays, some deep architectural guides, and these incredibly detailed visual design briefs.
Like the one that inspired that amber wire image.
Yeah, exactly. And these sources are like pointing a massive spotlight at the hidden financial risk of AI lock-in. And they make this really compelling case that most of the tech industry is just looking in the completely wrong direction.
The sheer misdirection happening right now it's striking. If you sit in onboard meetings right now, or review corporate risk decks.
The entire conversation is monopolized by model output.
Yes. Everyone is obsessing over hallucinations. What if the AI says something offensive? What if it gives a customer legally bad advice?
Which, to be fair, are absolutely real concerns.
Oh, totally. They are real.
Right.
But the architecture and strategy sources we're synthesizing today, they argue that this is actually a secondary danger. The real immediate threat to the survival of these companies is operational.
It's the concentration risk hidden inside that thin amber wire. I mean, so many organizations have just buried single-provider LLM APIs deep inside the DNA of their products.
And they aren't even looking at the wire.
No, they're just staring at the gray blocks, assuming the factory will just power itself forever. We're talking about a scenario where your entire business continuity is tethered to one vendor's pricing discipline.
Right.
Their uptime, their product roadmap, and their incredibly opaque quota policies.
We've become so fixated on the AI acting smart that we've completely ignored the basic supply chain mechanics of keeping it running.
Exactly, which is why we need to move past the theoretical today. Today is all about operationalizing that risk.
Getting into the weeds.
Yep. By the end of this deep dive, you're going to walk away with a concrete 48-hour rapid response agenda.
A real survival guide.
We're going to walk through how to identify your revenue-critical workflows, how to model potential provider outages, and how to estimate the actual P&L, the profit and loss impact.
And, crucially, how to build a tiering framework to actually protect your business.
Right. We are going from abstract theory to an absolute tactical checklist. And look, doing this work is not glamorous. Yeah. But it is the high-consequence work that separates mature operators from people who are just, playing around in an AI sandbox.
So to really understand this invisible P&L risk, we have to kind of look at the culture of tech development over the last few years.
The vibe shift.
Yeah, exactly. The sources make a point to highlight that it wasn't laziness that caused this massive structural vulnerability.
It was speed.
Speed won the market.
Oh, man. The culture of speed won is something anyone working in tech over the last 2 years has just felt in their bones. I mean, I can picture exactly how this happens in a product team.
Oh, yeah. You have this massive mandate coming down from the CEO.
Or the board right after they get back from some big tech conference in Vegas.
Right. And the directive is just...
put AI in everything. Yesterday.
Yes. So the engineering teams are under this immense pressure to deliver immediately.
So what do? They grab the most capable, most accessible LLM API they can find, and they just wire it directly into the support flows.
Then they wire it into the sales tooling,
Then the internal analytics.
and then the core customer-facing features. They essentially treated this massive, fundamental supplier risk like it was just a tactical developer convenience.
Right, like grabbing an open source library off GitHub just to make a user interface element work.
Exactly. But instead of a minor UI tweak, it's the cognitive engine of the entire company.
Wow.
The sources argue this is a profound failure of governance. Because when you integrate a standard API, the traditional mindset is, well, it's just a tool.
Sure.
But when that API is actively making complex decisions, routing workflows, summarizing sensitive client data,
Synthesizing information across your whole enterprise.
right, it crosses a threshold. It's no longer just a tool. It is a core infrastructural pillar.
But because it's delivered as a simple API call, it bypassed all the traditional vendor scrutiny.
Yes. The architecture reviews, the risk assessments that a company would normally require for any critical supplier, they just skip them.
Okay, I want to challenge this narrative just a little bit here,
Hmm.
because I can hear like an IT director listening to this right now and just rolling their eyes.
Let's hear it.
We've all seen software outages. If an API goes down, the pagers go off, engineering teams scramble, you post a quick status update on Twitter,
Yeah.
and a few hours later, it's fixed.
Right, the usual drill.
Yeah. So why are the architecture sources treating this as a massive existential business emergency? Like, why elevate this to a P&L event rather than just treating it as a standard IT headache?
Well, it becomes a P&L event because of how deeply the AI is embedded in the actual revenue-generating mechanisms.
Okay, unpack that for me.
Traditional APIs often just, pull data. AI APIs are increasingly processing the workflow itself. Let's trace the actual impact of a disruption. Imagine your primary LLM provider has an unexpected outage on a Tuesday morning.
A bad Tuesday.
Very bad. Or, perhaps more insidiously, they silently tighten their rate limits because they're trying to manage their own global compute costs.
So suddenly, your systems can only handle a fraction of the volume they did yesterday.
Exactly.
So the system gets sluggish, users have to wait a few extra seconds for a response?
See, that's the trap. It goes far beyond sluggishness. The workflows stall entirely. Think about a customer support queue that relies on an AI agent to triage incoming tickets.
Right, drafting initial responses, routing complex issues to human agents.
Yeah. If that AI layer is rate limited, the queue doesn't just slow down, it starts backing up exponentially. Service level agreements, SLAs, are missed.
And if you're a B2B SaaS company, missing those SLAs often means you legally owe your customers financial penalties.
Exactly. Real money is leaving the bank account immediately just from the slowdown.
And it ripples out from there, doesn't it?
Oh, absolutely. The sales team's tooling is stalled. They can't generate the personalized outreach or synthesize the call notes they rely on to close deals.
So pipeline velocity just drops.
The internal analytics dashboards that the executive team uses to make routing decisions, they just freeze up. You are literally flying blind.
So the technical trivia of a vendor's rate limit has immediately cascaded into a degradation of customer trust.
And a direct, measurable hit to the revenue line.
The financial exposure gets even more severe, though, when you look at how these features were actually sold to the market.
Yes, the sources highlight this specific scenario that is just terrifying for anyone managing unit economics.
The fixed-price contract trap.
That's the one. This is where the invisible risk becomes a tangible financial disaster.
Let's walk you through the math on that. Say you sell a software platform to an enterprise client for a fixed price of, let's say, $100,000 a year.
Okay.
And to win that deal, your sales team heavily promoted your amazing new AI-driven features. The client loved them. They integrate them into their daily operations. They use them constantly.
But the client is paying a flat rate.
Right. Regardless of how much compute those AI features consume.
And behind the scenes, you are paying your single LLM provider a per token cost every single time that client uses the AI feature.
Exactly. When you signed that deal, you modeled your profitability on the assumption that the API cost would remain stable.
You figured it would cost pennies per 1,000 tokens, leaving you with this really healthy gross margin.
Then the amber wire heats up.
Yeah. The AI provider looks at their own burn rate and decides, they need to reach profitability, so they change their pricing model.
Or they deprecate the cheap legacy model you were heavily relying on.
Right, and they force you onto their newer, far more expensive architecture. So your cost per API call triples overnight.
And because you're locked into a multi-year fixed-price contract with your enterprise customer, you can't just pass that cost on to them.
You are legally obligated to fulfill the contract, but now your gross margin has been completely cannibalized. You are essentially paying for the privilege of serving your customer.
Ouch. And if you multiply that over thousands of customers, this can erase several percentage points of gross margin across your entire business.
It doesn't just cause a bad quarter. That directly damages your company's valuation.
It stops being an engineering problem and becomes a crisis for the CFO.
Totally. We aren't just talking about code breaking. We are talking about unit economics fundamentally breaking.
Which brings us right into the anatomy of this lock-in. Because the immediate response from any smart engineer listening right now is going to be, look, if provider A gets too expensive or starts dropping requests, I'll just change the API key and route the traffic to provider B.
Problem solved.
The famous phrase? Yes. The sources quote this constantly. We can always switch later.
That single sentence, "we can always switch later," has done a staggering amount of damage in the technology industry.
It's the ultimate comforting lie, isn't it?
It really is. Teams tell themselves this to justify moving fast today at the expense of structural integrity tomorrow. It implies that AI models are basically commodities.
Like electricity.
Yeah.
You know, if you don't like the rates from the local power company, you switch providers, but your toaster still works exactly the same.
Right. But the text is very explicit that this is not how AI works. Traditional cloud governance has trained us to think about lock-in in a very specific way.
Right. For the last 15 years, the tech industry has been obsessed with building frameworks to ensure we wouldn't get completely trapped by AWS or Google Cloud or Microsoft Azure.
But cloud lock-in is fundamentally about infrastructure. It's about where your physical servers live, how your data is stored at rest.
What geographic availability zones you operate in, instances, storage buckets, network routing tables.
Exactly. And while it is incredibly painful and expensive to migrate from one cloud provider to another, it is a known engineering problem.
A Linux server is generally a Linux server.
Right. A SQL database can be migrated. You are essentially moving heavy boxes from one warehouse to another. But AI lock-in does not live at the infrastructure layer.
No, it lives somewhere much messier. It lives in the application and data layer. It lives in the very logic of how your product thinks and behaves.
Which is so much harder to untangle.
I was trying to visualize this, and it feels like thinking you can just swap the engine of your car because an engine is just an engine.
Okay, I like this.
But then you lift the hood and realize the steering wheel, the dashboard, the transmission, and the fuel lines only speak a proprietary language invented by the original engine manufacturer.
So if you put a new engine in there, the steering wheel literally doesn't know how to communicate a left turn anymore.
Exactly.
That captures the structural dependency perfectly, and the architectural guides break down exactly what those fuel lines and steering wheels are in the context of AI.
These are the sticky details that make swapping so dangerous. And the first massive hurdle is prompt engineering.
Yes. Let's dissect why prompts are sticky, because to a layperson, a prompt is just text, right? Like, please summarize this 50-page document.
Why is a sentence locked into a vendor?
Because in a production environment, you're almost never using a simple, like, please summarize prompt.
Right, it's never that easy.
Exactly. You've built these incredibly complex, multi-stage prompt chains. I mean, you've spent months tweaking specific adjectives, the negative constraints, the system instructions.
Just to get the tone right.
Yeah, the tone and the output format specifically for provider A, and the few-shot examples, too.
It's like you've learned to whisper to that one specific latent space.
That is a great way to put it. You know that provider A needs you to be extremely direct and use XML tags to format the output.
But provider B gets totally confused by XML and needs step-by-step reasoning before it gives a coherent answer.
Right. If you take that highly tuned prompt chain and simply point it at provider B, the output will likely degrade entirely.
The tone will shift, the formatting will break your parsing logic downstream, and the accuracy just plummets.
You haven't just changed the engine, you've changed the psychology of the worker processing the task.
And then we get to the data layer itself. The sources spend a lot of time on vendor-specific embeddings.
Ah, embedding.
This is one of those highly technical terms that hides a massive business risk.
It is perhaps the deepest trap of all. To explain the mechanism real quick. Embedding is a way of translating text, like a massive corporate knowledge base, HR policies, customer interaction logs, into an array of numbers called a vector.
Okay.
This allows the AI to understand the semantic meaning and the relationships between different pieces of information. It's how the AI efficiently searches your proprietary data to answer a user's question.
I like to think of embeddings as a library indexing system. You take your entire company's knowledge base and you organize it. But the catch is that every single AI provider uses a completely different mathematical map for their embeddings.
Yes.
It's like having your entire library indexed using a Dewey Decimal System that only provider A understands.
The dimensional spaces are entirely proprietary. If provider A turns your document into a specific coordinate on their proprietary map, provider B literally cannot read it.
Wow.
So if you want to switch to provider B, you can't just flip a switch in your code.
What do you have to do?
You have to take your entire knowledge base, delete all the old embeddings, pay compute costs to run every single document through provider B's embedding model,
Oh, man.
rebuild your entire vector database from scratch.
If you are a massive enterprise with terabytes of proprietary data, that sounds horrifically expensive.
It is, but more importantly, it is time-consuming. You cannot execute a database rebuild of that magnitude on a Tuesday morning during a vendor outage. It might take weeks.
And the same principle applies to fine-tuning artifacts, right?
Absolutely. If your engineering team spent hundreds of hours and hundreds of thousands of dollars training a model on your specific customer data to make it better at a niche task, those weights and algorithmic adjustments belong to that vendor's ecosystem.
They do not transfer.
No. If you leave the vendor, you abandon the intelligence you build.
The final sticky detail the text focuses on is product logic built completely around one provider's quirks.
Yes.
We're talking about latency expectations, context window limits, and output styles. Think about the user experience you've designed.
If your product is built around the assumption that the AI will respond in 800 milliseconds, because that's what provider A reliably delivers,
And you suddenly swap to provider B, who takes 3 seconds to process the same prompt.
your application might literally time out and crash. The software assumes the process failed.
Or consider context limits. If provider A allows you to upload a 100-page document for analysis, and provider B's architecture only allows 20 pages at a time,
Your core feature is now functionally broken for the end user. The product behavior itself quietly depends on the invisible constraints of the provider.
when you stack all of this up, the highly tuned prompts, the proprietary vector databases, the non-transferable fine-tuning, the hard-coded product logic, we clearly aren't just talking about buying software anymore.
No, we are talking about supplier concentration risk in a physical supply chain. Imagine you are manufacturing complex industrial machinery and you buy 100% of your specialized engine control units from a single factory in one region.
You have no backup supplier.
And your machine's chassis is physically molded to only fit that exact unit.
No mature supply chain executive would ever allow that to happen. It would be flagged as professional negligence in an audit.
Yet, in the software world, we currently have a very small oligopoly of providers sitting directly between the business and its mission-critical operations.
If they decide to squeeze you on price, or if they suffer a catastrophic infrastructure failure, you are squeezed. Your resilience is only as good as their operational competence. Okay, so we have named the invisible P&L risk. We have mapped the anatomy of the lock-in and exposed why we can always switch later is a total myth. We understand the amber wire.
Now comes the fun part.
Yes, this is where it gets highly actionable. How do we actually run this fire drill? We promised a concrete 48-hour rapid response agenda. Let's start the clock and put ourselves in the room.
The 48-hour drill is designed to cut through all the theoretical debate and force absolute clarity. This is an exercise that requires product leads, engineering leads, and risk officers all in the same room.
Okay, clock starts now. What's step 1?
Step 1 of the agenda is deceptively simple. List the 10 most AI-dependent workflows in your organization.
I say deceptively simple because in a lot of organizations, just finding the master list of where the AI is actually being used would consume the first 24 hours.
Oh, easily. Because, again, speed 1. Teams were quietly plugging these APIs into experimental branches that accidentally made it into production.
Discovering the actual footprint is often a shock to leadership.
It's usually a bad afternoon. But once you have that list of 10, the customer support triage bot, the automated sales email generator, the internal code copilot, the legal document summarizer.
You have to ask one brutal, uncompromising question.
The sources give us the exact phrasing for this question, and it is the linchpin of the entire exercise. Every single product owner must answer this.
Are you ready? What happens if our primary provider is offline, rate limited, or 3 times more expensive for 30 days?
I want to focus on the framing of that question because it is a stroke of structural genius. It doesn't ask what if there is a blip.
Right.
It forces the organization to look at a prolonged structural failure. 30 days, 3 times the price.
I'm going to play devil's advocate and push back on the premise of the question, because I know executives who would hear 30-day outage and immediately dismiss the entire exercise.
I've been in those meetings.
They'd say, when has AWS or Google Cloud ever been down for a month? It doesn't happen. Why are we running a fire drill for an apocalyptic doomsday scenario that has a near zero probability?
That is exactly the pushback you will get, and it is based on a completely flawed comparison. You are applying mature cloud infrastructure logic to an emerging, highly constrained AI ecosystem.
It's apples and oranges.
Totally. AI providers aren't just hosting static web servers, they are running massive, globally constrained compute clusters that rely on specialized, scarce hardware.
So a 30-day disruption in this space doesn't necessarily mean the website returns a 404 error page.
Right. It means the provider silently drops your rate limit by 80% to ensure stability for their new, massive enterprise whale clients.
Ah. So you aren't down, but you are stuck in the slow lane for a month while they scramble to build a new data center in Texas.
That distinction is crucial. It's not always a hard crash, it's a structural degradation.
And the 3x price hike scenario specifically targets the margin compression we talked about earlier with the fixed price contracts.
Yes. The 30-day question clears the room of theory. It removes the comforting illusion that engineering will just, figure it out over the weekend if something happens.
It forces the product teams to estimate the actual financial toll.
Exactly. If the support bot is effectively useless for 30 days due to rate limits, how many human contractors do we have to hire by tomorrow morning to manually clear the queue?
What is the emergency hourly rate for those contractors?
How many SLA penalty clauses will be triggered? Which specific revenue lines stall first?
It changes the conversation from an API annoyance to an existential margin threat.
During this phase of the drill, teams start realizing that their architecture has zero practical fallback. They will rapidly discover where their product assumptions were built on pricing that was basically a venture capital subsidized illusion.
Wow. Yeah, a lot of early AI API pricing was artificially depressed to gain massive market share and lock developers into the ecosystem.
If you built your entire business model, assuming those introductory prices would hold forever, this 30-day 3x price drill will expose exactly how fragile your unit economics truly are.
Okay, so we are 24 hours into the drill. We've gathered the product leads in a war room. We listed the 10 workflows. We asked the brutal 30-day question.
And the result is widespread panic.
Usually, yes. We realize almost everything is deeply coupled to one vendor, and if they degrade, we hemorrhage cash. How do we avoid paralysis here? Because we clearly cannot re-architect the entire company in an afternoon.
No, you cannot boil the ocean. If you try to fix every vulnerability at once, you will fix none of them. This is where the tiering framework comes into play.
The architectural guides are very clear on this. Not every workflow requires the same level of resilience. You have to categorize your workloads by critical business impact.
Let's use a structural engineering metaphor here. You are inspecting a house, you have load-bearing walls holding up the roof, and you have decorative trim around the windows.
If the decorative trim rots, it's annoying and ugly, but the house stands.
Right. But if the load-bearing wall fails, the roof collapses and people get hurt. You don't spend your emergency budget reinforcing the trim.
Exactly. And the sources provide a clean, rigorous 3-tier system to categorize these dependencies. Let's start with Tier 1.
Tier 1, mission critical. The load-bearing walls.
The text defines this as workflows where failure directly blocks revenue, halts customer delivery, compromises safety, or breaks core operations.
If a workflow falls into Tier 1, the engineering requirement is non-negotiable. You must have multi-vendor routing and regional fallback structurally built in.
Okay, multi-vendor routing sounds great in theory, but I've talked to developers who say building a resilient router is like building an entire secondary product just to manage your vendors.
It's not trivial.
It introduces latency, it adds complexity. Isn't that overkill? Let's walk through the mechanics of what a router actually does.
It is significant engineering overhead, yes, but it is the cost of doing business in Tier 1. A router means your system is designed so that when an AI request is generated by the user, it doesn't go straight to provider A.
It hits an internal intermediary gateway first.
Exactly. That gateway evaluates the request and the current health of the ecosystem. It says, normally I send this categorization task to provider A, but provider A is currently showing a 4-second latency.
And without the end user ever noticing, it instantly reroutes it.
Yes. I'm going to instantly reroute the specific request to provider B, translate the prompt syntax on the fly to match provider B's requirements, and return the answer.
It requires upfront investment, but it ensures absolute business continuity. And regional fallback operates on the exact same principle, right?
Yep. If provider A's US East servers go down, the gateway automatically routes the traffic to their Europe data centers. For Tier 1, a single point of failure is simply unacceptable.
All right, let's move to Tier 2. Important, but non-critical.
This might be an internal tool that helps the marketing team brainstorm campaign ideas, or a system that drafts internal meeting summaries.
If it goes down, productivity takes a hit, employees are annoyed, but the core revenue engine doesn't instantly stop.
The decorative trim. Or maybe the plumbing in the guest bathroom. It's a massive inconvenience, but the house hasn't collapsed.
Right. For Tier 2, the requirement is less intense. You do not need real-time, millisecond switching multi-vendor routers.
But you absolutely need a documented migration path, tested alternatives, and known quality thresholds.
So we don't have provider B wired up and running in parallel burning compute, but we have a literal document, a runbook.
A runbook is essential here.
It says, in case of emergency, here is the exact script we run, the prompts we use, and the API keys we need to manually switch this workflow over to provider B within a 48-hour window.
And you've previously tested provider B for this specific task. You know it's good enough to handle the workload even if it's not perfect.
And the engineering team knows exactly what steps to take by lunchtime if the primary goes down. It's a manual failover, but it is a planned one.
And finally, Tier 3, experiments. The text says single vendor architecture is perfectly fine here.
Yes. If a small team is just hacking together a proof of concept for a new feature or exploring a new capability, let them move fast.
Let them use whatever single API gets the job done fastest. Do not burden them with building abstraction layers.
But there's a crucial caveat in the sources. Tier 3 experiments must be explicitly time-boxed.
Time-boxed, meaning you can play in this sandbox for 60 days and then we formally evaluate.
Why is enforcing that time limit so critical to the architecture?
To prevent what the sources brilliantly call production by accident.
Oh, I love that phrase.
I have seen this happen in almost every organization. A small team builds a cool little experimental tool on a Friday afternoon. They're just messing around with a new model.
On Monday, they show it to the VP of sales.
The VP loves it and says, "This is amazing. Roll this out to the entire global sales team tomorrow."
And suddenly, a fragile, hard-coded, single-vendor experiment that has no logging, no error handling, no fallback, and no cost controls
is powering a core daily workflow for hundreds of people. The prototype just somehow becomes the product.
The time box forces a mandatory governance review. Before that Friday afternoon experiment becomes load-bearing architecture, leadership has to stop and say, okay, this works. Now we need to rebuild it to Tier 2 standards before anyone else touches it.
Exactly.
All right, so we've run our drill, we've tiered our top 10 workflows, we know where our vulnerabilities are.
The next step is where the real operational discipline kicks in. Building the AI dependency register and drafting the executive memo.
The fundamental rule of governance in any complex system is that you cannot manage what you have not named.
Right now, in most companies, these dependencies are entirely invisible.
They are scattered across abandoned GitHub repositories, buried in Slack channel histories, and hidden deep in Jira tickets.
The solution is creating a single, authoritative AI dependency register.
The sources gave us a highly specific list of ingredients for this register. I'm going to read through these required data points, and let's explore the mechanics of why each one is necessary.
Sounds good.
Let's start with the basics: provider, model, and use case.
That is your raw inventory baseline. Who are we buying the compute from? Which specific version of their intelligence are we relying on?
Because provider A's version 3 behaves very differently from their version 4.
And what is it actually doing for us in plain English? You would be stunned by how many enterprise companies do not possess a central document answering those three basic questions.
Next column in the register: system owner.
Accountability. When the 3x price hike hits, or the latency spikes whose phone is supposed to ring?
If there is no documented owner, there is no one actively managing the risk. It becomes everybody's problem, which means it's nobody's responsibility.
Spot on. Next is traffic volume and customer exposure.
Sizing the blast radius.
Yes. Are we talking about an internal tool that makes 100 API calls a day, or a core feature making 10 million API calls a day directly facing our Fortune 500 clients?
This metric alone often dictates whether a workload belongs in Tier 1 or Tier 3.
Next is revenue dependence.
This is where we tie the technology directly to the P&L. If this specific model goes offline, what specific dollar amount is frozen or at risk?
What are the SLA penalties? This is the data point that gets the CFO to stop looking at their phone during the meeting.
And finally, fallback status and evaluation status.
This tracks your actual operational readiness. Fallback status tells you immediately. Do we have an active router in place? Is there a documented manual migration path? Or are we entirely exposed?
And evaluation status.
That tells you if you have empirically tested the backup models to see if they perform well enough to use in an emergency, or if you are just guessing.
Okay, so we have this beautifully detailed, slightly terrifying spreadsheet. Now we face the hardest part of the drill, translating this technical reality to the C-suite.
The CIO, the CTO, the chief risk officer.
How do we draft the executive memo to communicate this upward? Because let's be honest, if an engineering lead just emails a massive spreadsheet full of API latency metrics to the CFO, it is going to go straight into the trash folder.
The communication strategy here is vital. The entire goal of this memo is to turn a vague, technical dependency into a material risk that leadership can actively govern.
You must shift the framing entirely. You have to stop talking like an engineer. Stop talking about token cost, context windows, and API rate limits.
The CFO doesn't care about tokens. They care about margins.
Exactly. You must reframe the conversation around concentration risk in the AI control plane. You're writing a serious business memo, not an engineering specification.
You must argue that AI governance no longer belongs in the R&D sandbox. It belongs inside the exact same rigorous discipline used for other material dependencies in the business.
You treat it like you would treat an audit of your primary physical supply chain or a review of your real estate footprint.
The memo needs to be blunt. It should explicitly state, quote, "We have conducted a dependency audit and identified that 40% of our core revenue paths are currently entirely dependent on the continuous uptime and current pricing structure of vendor X.
We have no secondary supplier for this critical input."
A 30-day disruption or price restructuring from vendor X would result in an estimated $Y million impact to our gross margin and trigger significant SLA penalties. We are requesting immediate authorization and budget to build multi-vendor routing for our Tier 1 workloads.
That is impossible for an executive to ignore. It places the risk directly in their lap in language they understand. It forces a business decision.
They either allocate the budget to build the safety net, or they formally accept the catastrophic risk.
That is the ultimate goal of the 48-hour drill and the memo. To force a conscious, documented business decision about risk tolerance rather than letting the structural risk compound silently in the background while everyone hopes for the best.
So we have executive buy-in, we have our register, we know our tiers, now we have to execute.
We have to do the actual work of untangling the wires. The sources lay out a vendor migration checklist for product stakeholders. There is a phrase from the text here that I think should be printed on a poster in every engineering department attempting this.
Let's hear it.
The goal is that swapping providers is ugly, but possible, not impossible.
It is the most realistic, intellectually honest goal you can set. Creating perfect, seamless, plug-and-play interchangeability between radically different AI models is currently a pipe dream.
They're too fundamentally different in how they reason, how they process prompts, and how they output data.
But you don't need perfection. You need a survival path.
Ugly, but possible.
Yeah.
Let's walk through this checklist. What is the quiet, unglamorous work that actually saves the day when the primary provider goes down? The first item on the checklist is abstraction layers.
We touched on this briefly with the routers, but let's explain the mechanism.
Sure.
The worst architectural anti-pattern you can commit is having provider A's specific SDK, their software development kit, hard-coded into hundreds of different places across your application's code base.
When I was reading the section on abstraction layers, the mechanical reality of an SDK clicked for me. Hard-coding a vendor's SDK into your app. It's like letting a utility company wire their own proprietary power outlets directly into the drywall of your house.
Oh, that's good.
If you ever want to switch power companies, you can't just flip a main breaker in the basement. You have to take a sledgehammer, rip out the drywall in every single room, and physically change the plugs.
That perfectly captures the architectural debt of a hard-coded SDK. An abstraction layer means you build your own universal outlet.
Your application just calls your internal AI service, And that internal service is the only thing that talks to the external providers.
It centralizes the swap. If provider A goes down, you rewrite the connection logic in one single place, the internal gateway, and the rest of the application has no idea anything changed.
You only have to change the wiring in one room, not in every wall of the house. Next on the checklist, standardized schemas. Let's break down response parsing and schemas.
Let's say you ask an AI to extract a user's name, age, and address from a messy legal document. Provider A might naturally return that data formatted as a nice, neat table.
Right.
Provider B might return it as a conversational paragraph.
Okay, so if your application's internal code is strictly built to only understand and process tables, switching to provider B will cause the app to crash.
Even if provider B found the correct information, the application simply doesn't know how to read the paragraph. Standardizing the schema means you force all AI models, regardless of who they are, to output their answers in one strict, universal, machine-readable format.
Like JSON.
Exactly, JSON.
It's like forcing all your global suppliers to use the exact same size shipping container, no matter what goods they're shipping or what country they're shipping from.
Because the port cranes only know how to lift one size of box. If you don't enforce the schema, the crane drops the cargo.
Precisely. Third on the list, logging.
Mhm.
Are you rigorously capturing quality, latency, and failures across providers?
Most engineering teams log hard errors when the API completely fails. But you also need to log how fast the model responds and whether the user actually accepted the AI's answer.
If you swap from provider A to provider B, and the latency doubles from 1 second to 2 seconds, you need your dashboards to alert you instantly.
You cannot wait for customers to start complaining on social media to realize your fallback plan degraded the user experience.
Next up, version control for prompts. We discussed earlier how sticky prompts are, how you sculpt them for a specific model's latent space.
If you are forced to switch to provider B during an outage, you cannot just guess what prompt structure works best for them in the heat of the moment.
You need to have versions of your prompts securely stored, tracked, and tested.
This is prompt version 1.2 optimized for provider A. This is prompt version 1.3 specifically tweaked to get the exact same result from provider B.
When the crisis hits, you pull the correct pre-tested version off the shelf.
And that leads directly into the most sophisticated item on the checklist, evaluation harnesses.
The text argues that mature teams need model-agnostic test suites to check output quality across candidate models before a crisis forces a decision.
This is the definitive separator between the amateurs and the pros in AI operations. An evaluation harness is essentially an automated grading system.
You feed it a massive data set of hundreds of historical examples of a task, say, classifying complex customer support emails into the correct department.
You run those same 100 emails through provider A, provider B, and provider C. The harness automatically grades their accuracy against the known correct answers.
And you do this continuously, running in the background on a random Tuesday when nothing is wrong.
Why dedicate compute resources to constantly testing backup models?
So that when provider A goes down on Thursday afternoon, you don't have to guess if provider B can handle the workload.
You aren't operating on gut feeling. You have empirical, up-to-the-minute data proving that provider B is 94% as accurate as provider A, but provider C is only 60% accurate.
You make an informed routing decision instantly. You are executing a failover based on hard math, not panic.
Executing based on math, not panic. That is the entire ethos of this drill.
And the final piece of the operational guardrails, setting SLO's service level objectives for uptime and latency. The sources emphasize that we need to stop treating AI calls like magic black boxes and start treating them like standard software dependencies.
Decide in advance what the product should do if the model is unavailable or simply too expensive to call.
We tend to treat AI as this infallible oracle that will always be there to answer our questions.
But structurally, it is just software running on a server. It will fail. Setting an SLO means the business declares, we expect this specific AI feature to be available 99.9% of the time, and we expect it to answer within 2 seconds.
If the AI provider cannot meet those metrics, what does your application do?
Right. What is the degradation path?
A mature operator plans the failure mode. If the AI is down or timing out, the product should degrade gracefully. It shouldn't crash the whole application or trap the user in an endless loading screen.
Maybe the Generate Summary button simply disappears from the interface, and a polite message says, summarization is temporarily unavailable.
The core application keeps working. The user isn't stranded. You planned for the boring, predictable failure mode.
We have covered an immense amount of ground today.
We really have. We started by recognizing the invisible P&L risk, the fact that AI lock-in isn't just about the PR risk of hallucinations, but about margin compression, missed SLAs, and the amber wire of vendor concentration risk.
We move through the deep anatomy of that lock-in, understanding why hard-coded SDKs, proprietary embeddings, and sculpted prompts make this so much messier than standard cloud infrastructure portability.
We gave you the blueprint for the 48-hour fire drill. We challenged you to gather your teams and ask the brutal question: what happens to our revenue if our primary provider is offline or 3 times more expensive for 30 days?
We learned how to mathematically tier our workloads, separating the load-bearing walls from the decorative trim.
We mapped out the AI dependency register, turning an invisible, sprawling engineering mess into a structured, governable business asset. And we discussed the strategic framing required to get the CFO to care.
And finally, we built the swap surface. The abstraction layers, the standardized JSON schemas, the evaluation harnesses.
The unglamorous heavy lifting that makes swapping providers ugly but possible.
Doing this work, mapping dependencies, building resilient routing logic, having those difficult conversations with procurement about establishing multi-vendor contracts, it is not the exciting part of the AI revolution.
It will not get your engineering team profiled in tech magazines.
But it is high-consequence, survival-level work. It is the architectural discipline that ensures your company outlives the inevitable turbulence of the AI supply chain.
It is the work that keeps the stable gray blocks from tumbling down when the external environment violently shifts. But as we wrap up, I want to leave you, our listener, with a final, lingering thought.
Something to mull over as you start drafting your dependency register tomorrow morning.
We've spent this entire deep dive obsessing over what happens if your main AI provider goes down. The solution, we've determined, is to build abstraction layers and complex multi-vendor routers. But let's take that logic one step further.
It's a structural paradox.
Yes. As you build these incredibly complex, intelligent, context-aware routing gateways to protect yourself from your AI provider, are you truly eliminating your single point of failure?
Or are you just shifting the amber wire?
Exactly. Are you just moving the vulnerability from the external AI provider to your own internal routing gateway? If your master router crashes because of a bad deployment, provider A, B, and C are all perfectly healthy, but they are entirely useless to you.
So the question remains...
As we build all these safety nets, who is guarding the guardrails? Thank you for joining us on this deep dive. We'll see you next time.